Welcome, everybody. Great to see you here. Got Rolf Sluice here with zkVerify Foundation, John Camardo, zkVerify Product Manager, Horizon Labs, and we are going to talk today about zkVerify, big picture, what it is, and this is the first live stream for our hackathon. So I've got this great screenshot of Trailblaze and its provably fair raffle. John, you want to talk for a minute about what Trailblaze is doing with zkVerify before we get into the technical details of what it is that we're doing?
Sure can. And thanks for the intro, Rolf. I actually have some pretty cool, exciting and late-breaking news. This graphic actually underrepresents a little bit what the zkVerify point allocation is going to be. We've actually upped that number to 1,500 zkV points, which are testnet points, which will potentially one day be redeemable for something on actual zkVerify mainnet. But essentially, Trailblaze is deploying, I believe they're deploying this raffle protocol to ApeChain, and essentially you'll be able to participate and have a chance to win a part of this prize pool. And the actual drawing, so essentially like the random number generation that essentially goes into selecting the raffle winners, will be provably fair, as you mentioned before. So there'll be a zero knowledge proof that attests to the validity of actually generating a random number that was truly fair. So really cool stuff. I think it's like one of the first real applications on chain on a mainnet that zkVerify has been used. So really excited to be working with the Trailblaze people, and definitely get involved if you're interested.
Nice. Thanks for the overview, John. Yeah, just wanted to start out with this exciting use case. And this is an example of things that we can do with zero knowledge proofs that can't be done in the real world. If you're doing a lottery at the state level, you just got to trust that the lottery is being run fair. But with zero knowledge proofs, you don't have to trust. You can see by the mathematics itself and the verification of the proof that things are being done in a fair way.
It's kind of a good question, actually, before you go on. Do you ever play the lottery?
No, I'm not one of those people. When I play the lottery, I feel like I'm throwing my money away. I just like things that are that I have a little more control over. Maybe that's my personality. Maybe I'm too controlling, but no.
There are situations where I'll play it. There are times when the jackpots get to be so significantly large, and your chance of winning is, still very small, but it turns into a positive expectation if you buy a ticket. But I always sit there and I watch the drawing, and it lasts like a whole 2 seconds. But there's no real guarantees that the balls that they have in the thing that spins everything around and then shoots a ball with a number out on it, there's no guarantee that there's actually a full set there, I guess, now that I think about it. So I guess I hadn't really thought about that till now, but this would be a great way to revolutionize, I think, lotteries and raffles, where you could actually have a guarantee that.
Well, I think the ball is being pushed around and brought out. That you can sort of see that that's fair. How do you know that they totaled up all the amount of tickets that were bought?
Well, that's true, but I guess my point is, like, how do you even know that there's a number 1 through 99 or whatever the number of the numbers that can exist are in that drawing? So there's a lot of like weird stuff that we take for granted.
There is. I mean, there's a big company here locally, Scientific Games. They run a bunch of state lotteries. They had just real strict controls. I mean, I would trust that organization. It's better not to have to trust. All right, so let's talk a little bit about our hackathon. We kicked it off 2 days ago. People are able to register today. We already have registrations happening. zkVerify put up $15,000 for prizes. Horizon Labs put up $5,000 for prizes. We already have Hyperbridge as a silver sponsor coming in for $3,000 in prizes. Sindri as a sponsor for $1,000 in prizes. We really excited about this because this is during this part of the year, right after DevCon. where folks got excited about building, and we have this kind of lull leading into the holiday season where people want to earn some money to be able to get Christmas presents and stuff like that. So we've got a number of these different live streams with different people involved with zkVerify to talk about what's going on. So the first one is obviously right now. Next one is Thursday. I got it here as 8 a.m. Eastern Standard Time. This is a perfect time for Central European and Asian viewers. And so we're going to do an architecture overview and some developer tools. And as these workshops and presentations continue on, they're going to get progressively more technical. This x.com live stream, I encourage you to ask questions here. John and I aren't super technical on those questions, but as we get into these other live streams, there's going to be more and more chance to ask technical questions. Of course, you can join our Telegram and ask questions. And if you don't want other people to know what your projects are, it might be possible that we can get into small Telegram groups. Certainly, we have a hackathon channel on our Discord. We've got a lot of people that are pretty excited about that. So this is an online hackathon, and it's going to progress all the way through to our live award presentation on the 12th of December. So let's get a little bit into what zkVerify is. And I've got the CTO of Horizon Labs here, Zane Chang. Oh, I took his name off. I shouldn't have done that. But he created this presentation. I chopped it down a little bit. He gave this presentation last week at the ZK Accelerate conference put on by Inganyama before DevCon in Bangkok. It was really well received. And I'm just going to go over some of the highlights of it here and talk about what zkVerify is, but also why zkVerify is. And I'm going to ask John to jump in here on some things. But big picture, I always like to start with why we're doing something, because this gives people an idea of what it is that you're doing now, what you're going to be doing in the future, and how it can apply. So it gives them kind of a framework to think about what it is that you're doing. So our team's been doing zero knowledge proofs since we launched Horizon as Zencash back in 2017. So one of the original ZK protocols. And we have a great team of cryptographers, developers, all sorts of people that are able to take the complex ideas around zero knowledge proofs and put them into production in a reliable way. And so what we saw out there was that there's a lot of opportunity for zero knowledge proofs to improve the Web3 space, as well as Web 2 to Web 3 and other things like we talked about earlier with provably fair raffles and things like that. But it was constrained, and it was constrained into the EVM design of being able to verify using a single elliptic curve. And so our developers and product managers like John came up with the idea that, hey, if we can verify the newer technology zero knowledge proofs, then people can design applications with newer zero knowledge proofs and verify them. And if we set up a system that people can verify the proofs in a decentralized, permissionless way, and that's focused on that, long term, we can be the fastest and lowest cost way for projects and applications to verify their ZK proofs in a public way. So already there's multiple types of verifiers for Starks, for Snarks, for different types of technology. Our developers continue to improve the performance of the verification by putting some of the primitives into the code. And we're going to continue to innovate. So we are innovating by adding new types of verifiers. And I'll ask John to speak to that in a little bit, and then upgrading verifiers as the technology improves. And so zkVerify is not an EVM. It's not a smart contract blockchain. It does gas and governance with the token, and it does verifications.
Just one thing to quickly jump in there, Rolf,
Yeah.
on your last slide.
Absolutely.
I do want to point out, under point 2 on the right-hand side, this is an open source blockchain, and like we encourage everybody to participate once we're on mainnet, and governance and staking and all that kind of thing. But there is an opportunity right now to build, and I think we'll talk about this a little bit later, but there's an opportunity if you're interested in building your own verifier, you have a verifier that needs to be custom written, or you want to just contribute one that we haven't yet implemented. Definitely encourage, this is open for the community to contribute, verifiers, or frankly anything else on any other sort of component of the blockchain, to the extent that that's interesting, or within your skill set.
And by making this open source and with a permissive license, it also, since the system is built on top of the substrate framework, zkVerify is contributing back to the substrate community as a whole. Earlier this year, we were at a Polkadot Decoded conference. There were people excited about the palettes that the zkVerify team is developing. So we got Web 2, Web 3, and Web 4 defined here. I've also, in talking to some folks, Web 2.5. So those are, and so we'll just say that Web 2 is centralized applications. Web 3 are things that are decentralized, and Web 4 are the future. And in doing these types of things, especially to allow AI to interface with applications, and to do things in a provably fair way, we see that there's just going to be more and more ZK proofs being created. And the ZK proof, it takes a lot of computation to create a proof. Of course, it takes a lot to design one, implement it, and then create it. That's why some of the partners that we work with are ZK proving networks. But there's also ZK proofs that can be generated on mobile devices or your own computer. And in order to make sure that the proof was done properly, it needs to be verified. And for some of these applications, it makes the most sense to have them verified publicly in a way that isn't controlled by any one organization. So that's why we think a decentralized blockchain that's permissionless, that can verify proofs, is going to be very useful. So let's talk a little bit more about the design of zkVerify. Our next live stream on Thursday is going to go over all the tools on how to develop with it, and models to be able to do things. Today we're going to talk about what zkVerify is. And we've been up and running since March in testnet, and with continuous improvement and additions to the system right then. And we're working to get to mainnet in Q1. And so there's a lot of things to bring a blockchain live. John is going through all of them, has a big tracker of them. But one of the things that's really important is a security review of the blockchain. John, now that I'm thinking about that, can you talk about where we're at on doing a security review and the other steps that are required to go to mainnet?
Yeah, and it's a good point. There are so many things that are required for bringing an L1 actually live to mainnet. So, I mean, at the highest level, and again, just talking a little bit about the architectural decisions that we've made to essentially use Substrate as the framework. We have the ability to configure everything from the number of validators that are in our sort of active validator set producing blocks, down to the minimum required amount of tokens that are needed to nominate a validator to become part of the active set. There's things around governance. So we're kind of going through, in super excruciating detail, all of these different things, socializing internally and making sure we collectively sort of agree on, this is the right, most secure, which is our optimization function, security, the most secure configuration. And now we're actually working with a couple of different partners. So we just kicked off our audit actually today. The audit's meant to go through and detect any potential vulnerabilities, make sure we close those out before we get to mainnet. We have an external party that's going to be doing another sort of code review on top of all the code reviews we'll do internally. And yeah, I mean, I think we have a couple of other parties that we want to rely on, both internally and externally, to help, configure and fine tune some of these details to make sure that, again, we have the most secure possible blockchain configuration for the launch. And then subsequently, as we chug along, we change things so that they reflect, the community at large. And there will be a big portion of governance that's dedicated to people, inputting their thoughts on maybe things that need to change, configurations that need to change, and then there'll be community-wide votes that actually are on chain and get implemented sort of automatically without very much external intervention.
Yeah, and we're setting the system up from the very beginning with when I say we, it's the zkVerify Foundation that's setting it up. There's DAO. We're going to be using the Polkadot forms of governance. There's such great resources that have been built through the Substrate community. So here's what the verifiers that we've got right now. And some of these primitives are put in, I don't have the right word for it. John, you probably do, but I know some that we do in the WASM, in the runtime, and then other are core components, and we put them in the core components of the validators, the verifiers, to be able to make them run at much higher speeds. Anyway, so we got Groth 16 on 2 elliptic curve pairings, the BN254 and the BLS 12381. I know there's a lot of ZK applications out there that are designed to work with Groth 16. We just implemented the space and time proof of SQL verifier. So Space and Time announced recently their proof of SQL blockchain, and the using the BLS 12381 curve, it's more secure and in some cases higher performing. And those proofs are going to be able to be verified if they need to be verified publicly on zkVerify. For the RISC-0 ZK virtual machine, beautiful virtual machine, we have a Stark verifier for it. So you could verify Stark on an EVM, but it's very expensive. Whereas on zkVerify, if you're going to use RISC-0 to create a zero-knowledge proof, instead of taking the Stark and then wrapping it in a Groth 16 proof to verify on an EVM, you send the Stark to zkVerify directly. It's faster and it costs less. Ultraplank, one of the Noir one of the ways that you can develop with Noir is using the Ultraplank proof. So one of our design partners is using Ultraplank. So we made sure that we got that verifier written and implemented it and tested. And then when we first started out, and we still have people that are interested in doing this, we thought that ZK rollups would be really interested in doing this. And I think as we progress and go through the idea that verification is a modular and composable layer of the Web3 stack, that there will be individual ZK rollups that will be using ZK Sync Era or our Polygon CDK and will want to take advantage of these verifiers. John, what else we got in the pipeline for verifiers that you think are coming soon?
We've got quite a bit in the pipeline. Right now, internally, we're going through a process of actually kind of, I guess, modularizing even further the verifier architecture. So we're, to your point before, we're moving some of the more core cryptographic primitives into the native part of the software, and then keeping some components in the WASM. The WASM is, the runtime environment. It's, where we'll store things that maybe need to be changed more frequently, because we're actually able to update that those components on a as needed basis without a hard fork. The native components should be more static and therefore will require hard fork. So internally, you're going through the process of modularizing, like I mentioned before, and that's going to proceed for the next maybe month or so. Externally, we have, I think, three or four organizations that are helping us implement some other verifiers. I think we have a Starkey, Plonky2, There was some talk around SP1 as a verifier, I think Halo 2 as well. So we have a number of these in the pipeline, and once we've done our sort of internal refitting of these things, we'll get back on the track of continuing to maintain and updating these verifiers as new versions come out, but then also looking forward and trying to spur on the innovation that you mentioned before by adding potentially, innovative new verifiers that people may want to begin experimenting with, kind of like we've done with the proof of SQL verifier here.
Yeah, and the more we get into it, the more we see people developing unique types of zk proofs, whether it's Binius or certainly zk virtual machines are a really neat way of generating proof. The way that I understand it is that you have a zk virtual machine host, and you take some Rust code and you run it as a guest application, and it generates the proof of proper execution. And the different zk virtual machines do that in different ways. Some of them model the RISC-V microprocessor, others do MIPS. I think we're going to want to have intermediate verifiers. That's what I call them, like the Stark verifiers or the Plonky 2 verifiers for each of those, so that we can have the people that use the zk virtual machine generate the proofs as quickly and as inexpensively as possible, and verify them as quickly and as inexpensively as possible. So I think longer term, we're going to have verifiers for every zk virtual machine out there. And, there's different use cases. For a long time, people have developed zero-knowledge proofs in domain-specific languages like CIRCOM or Noir. There's machine language-specific ways of generating proofs. zk virtual machine, like I said, space and time is a zk coprocessor, so able to prove the state of a SQL table at a specific point in time. There's roll-ups, so there's many different applications for it. And for a long time, when we talk to people about zk proofs, we get the feedback that they're slow and expensive. And we're trying to change that mindset, that with the newer zk developments and with the optimization that we do for verification, instead of having zk proofs take many minutes and cost many dollars, it can be done in seconds for pennies. And that's going to change the way that zk proofs can be used. I mean, private voting and private polling has always been something that would be a use case. But when it costs like $5 and takes 20 minutes to create and verify a proof for polling, that really reduces the use cases significantly. So if instead you could do it, like I said, within a few seconds for a penny or two, that works a lot better. Okay,
just
so
a shameless plug really quickly. I had an op-ed that came out very, very recently. Maybe we can post it in the Twitter comments, but about private voting and how it could be actually enabled with zk proofs and ultimately through zkVerify. One other very, very quick thing to say. We talked a lot about efficiency. I just want to point out, we actually did something cool recently where we moved our Groth16 verifier from the WASM to the native, as I was mentioning before. And I think we have a 5x speed and efficiency improvement over what you can do on Ethereum. And the cost of verification will go from, $5, $10, whatever it is today on Ethereum, to probably, I think we're going to end up on mainnet being maybe a tenth of a penny or less. So really, really significant, efficiency gains and cost gains when moving things, even as, I guess simple as Groth16 into this environment.
Yeah, and so it's great that once we got into this and decided to do it, we saw that there were so many opportunities to go in many different directions. I think it's hard to go wrong by doing performance improvements and reliability and security. One of the reasons that we like doing hackathons is that the people that do the hackathons, they come up with creative ideas that us, as being dedicated to making the system work, to making the blockchain work, and making sure we don't necessarily come up with these ideas. And so one of the developers said, well, I don't need to involve a smart contract. I want to make a Telegram app. And so he made a Telegram app, and it gated access to a chat. And the way it gated access to a chat was the person had to prove that they owned a certain amount of a token. And if they owned a certain amount of token, it generated a ZK proof using the RISC-0 ZK virtual machine. And then it sent the proof to zkVerify to be verified. And once the proof was generated or created and verified, then that person was able to enter the chat. So you didn't have to publish what your wallet address was. You didn't have to go to a centralized token proof type application to use. You could use zero knowledge proofs to anonymously demonstrate that you owned a certain amount of token, and that got you into this special Telegram chat. So very creative use. Here's a picture of the developers and a couple of our team members that you will hear on future live streams. But it's like these creative things when people, they didn't necessarily, when we first started doing this, we thought, oh, everybody wants to use a smart contract. And so we need to make sure that we integrate everything into EVMs. And it's not necessarily true. It's not necessarily true that people want to integrate everything with a smart contract. In some cases, they just need to publicly verify the ZK proof so it can then be used for other purposes.
One thing I want to bring up here, this is a great example in my opinion, because it's super simple and easy to understand. But if you kind of take a step back and to think about the principles that are employed here rather than the specifics of the use case, you can start to come up with some very interesting other use cases. So one of the things that I think about a lot is how much money is collectively lost because of data breaches, because you sent some kind of information about yourself, whether it's your crypto holdings or your social security number, or even typing in a password. You're sending this all over the wire, and essentially sending my password, and even if it's in encrypted form, to a service to then verify my credentials and log me in. What if you never had to do that again in the future? And instead of sending all that data over the wire, you could instead just send a proof that proves that you are in fact a United States citizen, you are in fact over the age of 21 or 18, whatever the case is. How much money could be potentially clawed back by everybody just by reducing fraud and breaches of private information. I think there's a ton of use cases that could come of this, and this is a really great super simple example of how to very, very minimally use zero knowledge proofs and gating access to a chat. So I would encourage people to think about that as they go through this hackathon. Where are the big sort of meaty problems that we face today, and how can we maybe exemplify a use case that could be extrapolated further during the hackathon?
I agree that we have big problems that need to be solved with ZK proofs, but for a hackathon, I always consider people to say, hey, build something in a small provable use case for someone that you can know that can make it work. Like whenever we're talking about voting, people are like, yeah, we need to change the way the United States votes. I'm like, well, how about you change the way that they vote for high school class president at your local high school? Because the administrator and the principal are putting their finger on the scale and choosing people that they use. So why don't we set up, verifiable private voting at the high school level, and we get people seeing that it actually works. So anyway,
fully agree. By the way, fully agree.
Yeah, prove it in a controlled environment and grow it up from there. All right, so this was the way that the zgate application used. So it sent the proof right to the zkVerify interface, and it used, I think it used, at least if it was being built right now, you would use the zkVerify JavaScript library that's available on NPM. And if you go to our website describes as hackathon. There's links to all this stuff at the bottom. There's even the command on how to build this package on your machine. So we've got helper applications to make things easy for you to use. But so this is the first way that you can get proof verification done within your application. You send it, and one of the validators verifies it. When 2 out of 3 validators verify it, it gets posted to the blockchain. Our blockchain has a 6-second blockchain time, and you get verification that the proof was correct. So this is the first way that we do things. Now, in some cases, smart contracts want to be able to use the verification information. And so we've already integrated our testnet with 3 other testnets. So we've integrated it with Ethereum's Sepolia, with the Ape Chain Curtis, and the Horizon Eon testnet. And we have a grant from Arbitrum to integrate it to the Arbitrum 1 testnet. So we're going to be doing that soon as well. And what this lets us do is, and I'll explain how this works, at least at a really high level, after I talk about the 2 different ways that it gets from zkVerify to the other network. So one of them is we take the receipt of the verifications and we send it through a high-speed centralized bot. So it just takes the receipt and sends it directly to these other networks in a centralized bot, and that's done quickly, and it's not done in a decentralized way. But when you're working with zero-knowledge proofs, you're sending the proof, the digest, or at least the digest of the proof, and a hash of the verification, and it goes to these other chains where they're accessible. The second way is we're really happy to be working with Hyperbridge protocol. And with Hyperbridge, we'll be able to send it to other networks in a decentralized bridge. Hyperbridge is on mainnet. It's up and running. They're actually one of the co-sponsors of our hackathon. So really, really happy to be working with that organization. And
just
yeah, go ahead.
One call out I want to make, I guess PSA. Hyperbridge is on mainnet, but unfortunately, we don't have Hyperbridge live on our testnet quite yet. It's currently going through the process of implementation. So I just want to temper expectations there a little bit. We are super excited for them to be partners, and we are working very hard on the implementation here. The other big thing, though, is I do want to call out, like, the point of these 3 slides being in succession is to show essentially you have optionality on how you want to do this. You can go all the way from the Web 2 to the Web 2.5 case, where you're spinning up an app, sending proofs directly to the blockchain, listening for a node or many nodes to actually verify the proof, all the way through I'm in a Web 3 decentralized setting. I need everything to be decentralized. I want messages delivered back to my smart contract that give me the verification or the receipt of the verification that I need. So there's a lot of optionality here, and that's what we've been aiming to actually enable for folks. To the extent that your needs aren't met by any of these three options, we're happy to take the feedback there, and please reach out on Twitter, Discord, whatever the case is. Sorry, X or Discord. We'll be happy to think through other ways of actually delivering these receipts to the extent that your needs aren't met with any of our solutions so far.
Yeah, good point, John. All right, so we'll talk a little bit more about how that data structure is set up. And this is dangerous because I'm getting to the edge of my knowledge here. So I'm going to talk about these receipts. We're going to have it set at some point that when you send the proof to zkVerify, you'll also be able to indicate which, if you want a verification receipt sent, and if you do, which chain you want it sent to. That way you don't have to pay for things that you don't need. And the aggregated receipt data structure basically takes different types of proofs. So this is a heterogeneous type proofs, and puts it in. When the proof gets sent to zkVerify, we do a digest of the proof. The proof gets verified, and then a hash of the verification is created. These hashes of the verification are aggregated into a Merkle tree, and the Merkle root hash is sent to the other blockchains. And this Merkle root hash is sent to the zkVerify smart contract that exists on these other blockchains. And so smart contracts are able to query the zkVerify smart contract on their own chain to find the hash to make sure that the verification of the proof was done properly. So hopefully that makes sense to you. But this is
I can attest to the validity of that statement.
Okay, good. But basically, by doing a Merkle tree and sending hashes of the verifications, it's a much less expensive way to demonstrate that the proof has been verified. It also lets you send, it really makes zkVerify to be kind of the center point of a network of people wanting to do zk proofs. So we have zk proofs that come in from all sorts of areas to zkVerify. We verify them, and then we can send them to all the other places that they're needed, which means you can verify once and demonstrate that the verification was done in many other places. We really think that we're going to be, a main part of the way that zk proofs are being done going forward. So we have the three ways to do this. So first off, it comes into the zkVerify blockchain, and you can see right away when it's verified. Second, it gets posted. It gets included in a block on the blockchain. And then third, the receipt gets sent as part of an aggregated Merkle tree to other chains. So that's how it works, big picture. Now let's talk a little bit about our roadmap, things that we've done so far today. And if you have questions on this, you can certainly ask the questions in Twitter, and I'll see them show up here. And then John and I can work to answer them. Also, if you have questions, please feel free to go to our Discord or Telegram, ask questions. Where's the tools for this? What are some good ideas? What do you think of this? We got our very experienced zk cryptographers, developers, all different people monitoring those discussions and ready to jump in and answer. But yeah, John, if you want to talk a little bit about big picture, what we've done so far and what we're going to do next, that'd be great.
Yeah, zooming way out, I mean, this goes all the way back to the beginning of the year, and you already called out that we've been on public testnet, since I think March, maybe even a little bit earlier in kind of private mode. So we started out on this idea that we were going to be verifying proofs coming from zk rollups, and so you can see, like, we started with a Flonk verifier, we set up Polygon CDK, roll up and all that kind of thing, and then very quickly pivoted kind of away from the roll up use case, primarily because rollups decided that they wanted to start cryptographically aggregating proofs, a little bit different than our aggregation method. And we kind of publicly launched with a couple of new verifiers. So you can see we went to Groth 16, Risk 0, and we did implement another roll-up verifier because we were getting a lot of feedback around ZK Sync era. And then in Q3, throughout this time, we've been adding components to our blockchain and features to our blockchain that were going to enable us to actually launch it, hopefully very soon. So we launched our incentivized testnet in Q3. Right now, the tasks are primarily centered around building a verifier on our testnet, and we've gotten a couple of takers on that. It's worth noting we also launched a grant program here, and I think we've had a couple of applications come through there. Happy to have people continue to submit through the grant program there. And we really started in Q3 to integrate a lot of external components that are going to help make the chain more accessible and more fully featured. So we started on our bridge integrations there. We're going to continue those in Q4. We've started a number of other integrations with explorers, with faucets, to make sure that we're getting people the ability to use the testnet in a useful manner. And right now we're obviously in Q4. So we are refining a little bit our incentivized testnet plan. We're putting together some packages that might help incentivize groups of developers who may want to build an application that end users ultimately use, but maybe that application doesn't expose all the cryptography to the users. We're trying to build a package that'll kind of incentivize both the users to use the application and developers to build the application that sends a proof to zkVerify. We've done a number of hackathons and workshops, and this is kind of our maybe cornerstone hackathon for the year. And right now, the team is, like I had mentioned before, very much heads down in terms of preparing everything, checking all the boxes that are needed for mainnet. So that's kind of where we're at. We have these additional verifiers that we want to continue to add. We're going through this refactoring process right now. But it's really a lot of refinement while we march toward mainnet, and then the world of opportunities kind of opens up pretty significantly from there. So a lot more cool stuff to come, and we'll probably publish an updated roadmap in the beginning of the year once we've checked all of our boxes for mainnet preparation.
Yeah, thanks, John. So a couple of things that I wanted to call out as I was thinking about your discussion there. So just like we started off this presentation, certainly go check out Trailblaze on 8chain. So Horizon Labs has been working with Arbitrum and the Ape Foundation to launch 8chain, which is specifically for gaming. And so Trailblaze came up with the idea to do a provably fair raffle, so generating ZK proofs to demonstrate that it's a fair raffle, and then those proofs get verified on the zkVerify testnet. There's another game, and I'm not sure if they've been public about this yet, so I'm not going to mention who they are, but they generate randomness. So randomness is really important for games, especially games where you have like first-person shooters or character roles or other things like that. And there are games that haven't done the randomness quite as well as they could have, and so they've been somewhat predictable. So generating randomness and then using a zero-knowledge proof to prove that the randomness is actually random and out to a number of specific digits is really useful to make sure that the game is going to have good gameplay and can't be gamed, as it were. Anyway, that gaming organization is going to launch a game, and it's going to do the provably fair randomness and verify the proofs on zkVerify while we're still in testnet. So very cool application. So the Horizon Labs business development team has done an outstanding job of talking to lots of different projects out there, come up with lots of different ideas. And like John said earlier, we want to hear from you. If you have an idea and you see that maybe we're not able to help you with that idea yet, but because we need verifiers or possibly a different way to interact with the system, let us know. We want to make this the best system for ZK proofs to be verified in the space. So let's talk a little bit about Oh yeah, jump in.
Can I just say one interesting, I don't know if it's interesting to me, one point on randomness and provable fair randomness. I was running the other day. I added a bunch of songs to a playlist that I wanted to listen to on my run, and I skipped ahead. I put the playlist in shuffle mode, which theoretically would use a random number generator, right? And I skipped a song, and then I was like, I actually want to go back and listen to that. So I went back, and then I was like, actually, I don't want to listen to that. Went forward again. It got me to the same exact song. So like the random number generator that it's using, and this is maybe a really bad example of the random number generator. I don't use Spotify. I don't know if Spotify is better, but like random number generators in a lot of places in a lot of implementations can actually be deterministic once you kind of set the seed and there's a sequence of numbers that you'll get to. So I think that there are really interesting use cases of ensuring provably fair randomness. And this was just like a really maybe bad example, but one that I think is really interesting of a bad implementation of a random number generator, or at least one where I would maybe implement things a little bit differently.
Well, in this case, it just bothered you. In other cases, it can cause major problems, cost people lots of money, make an application that would otherwise be awesome, not so cool. So just some ideas around these types of things. When we talk, as you imagine, we got to explain ZK proofs to people outside the industry all the time. So I kind of break it down into two ideas. One is that you can prove that computation happened, or in the words here, proving computational integrity. So verifiable randomness, first one on the list. Provably fair games, that you want to do things. My son's computer science at university, and he's training a llama model on playing chess. And I'm like, can't you just play chess against Chat GPT? He's like, no, it cheats. So I'm like, I had no idea. You'd think that a large language model would be able to, if it was playing chess, know what the rules of chess are and make sure it followed the rules. So maybe if you're, doing something with AI and you want to make sure that the AI actually follows all the rules, or if you use an AI for legal purposes and you're in, I don't know, Montreal, maybe you want to make sure that your legal AI uses all the legal type things that are applicable for Montreal and not the ones for, say, California. So there's a lot of things that as you get more complexity into it, that you want to prove that the data sets are done properly with AI, or that rules are followed as things are done. And then, financial proofs. John, you've got a lot more background in the financial industry than I do, so maybe you can talk to this. I just try to stay away from the financial industry.
Yeah, I mean, I think a toy example of this is, again, kind of like what you mentioned earlier with the proving that you own some amount of tokens or NFTs in order to enter a chat. I mean, there's plenty of things that could be applied that could be expanded to, like proving that you're an accredited investor without revealing any of your bank account information, right? Which theoretically, somebody, if they wanted to verify that you're actually an accredited investor, would have to see, your essentially your income statement and your savings and checking accounts. There's plenty that can be done here. One thing that I wanted to interject with, though, outside of financial proofs, I've been brainstorming. My brother's pretty big into film and photography, and there's quite a lot of literature about ensuring that images or videos aren't doctored or created via some kind of AI. And there's plenty of weird things that people post on X every day that could lead you down some really dark and interesting paths that might lead you to believe false things are actually true. So I would personally love to see something around ensuring the authenticity or provenance of a photo is actually legitimate, came from a camera, and wasn't altered in any way that isn't cropping or making something bigger or smaller, for example. I think there's a lot to go on in that case, or in that sort of use case area, in terms of like literature that people have posted publicly online. I was doing a little bit of research myself last night.
Well, I was looking to get ideas on this. I was looking through GitHub for different types of projects, and there's a beautiful project involving pictures where you can do a ZK proof of the original photo, and then you can prove that any cropping or other type maps to the original photo. But just like a lot of the other ZK applications that are on GitHub, a lot of them seem to have been built for a while and then abandoned. And I try to figure out why those were abandoned. And the only thing that I can come to is that as they get to when I was working for Cisco Systems, one of the sayings that we had was price is always part of the design. So price and ongoing revenue that can come in. So you need to be able to have a system that brings in revenue, but you need to have something that's not too expensive to use. And for a lot of these GitHub projects that people put a lot of time and effort into, I believe that they ended up being too expensive to run for what people would actually be willing to pay for them. And again, that gets back to why we're doing zkVerify. We really want this to be a way to enable newer types of ZK proofs that are more optimized for the specific application, and that can be created perhaps on users' individual machines or mobile devices. So they have essentially zero cost proof creation and then verified for very small amounts of money. And the other aspect when we talk about zk, and of course when I helped co-found Horizon, and we started out as private payments, and it didn't work out that great just because there wasn't enough granularity. There wasn't enough way to stay in compliance with regulation and things like that. Whereas there are people that are creating, or applications that are creating private payment systems that are compliant with regulators. For example, Pay gives you the ability to send and receive USDC without being able to while hiding the amount of USDC that's sent, which if you look at it in the business world, that's a really useful application because, most people know, like in the business world, I used to be a business owner. And so I'm like, well, it'd be really hard to pay people in Bitcoin because all your competitors know what you're paying your suppliers, what your customers are paying you, what you're paying every one of your employees, all that kind of stuff. But if you had some way of doing some type of privacy while still maintaining regulatory interactions, that would put crypto payments into the business world. And so I think there's people that are solving this. And there's also dark trading that's being done. So people that move a lot of trading on DeFi, they want to be able to do this without the other people seeing what it is that they're doing. So one of our design partners, Singularity, is building a really cool dark trading application. So this gets to privacy-preserving transactions. And so it's not all or nothing. It's not like everything is going to be private and everything's going to be hidden. Unfortunately, when you work in that world, it's too easy to have other people accuse you of being just a tool for criminals to use. And it's really hard to defend against that. So having the system for being able to verify proofs and then encouraging many different people to create projects that use these zk proofs in privacy preserving transactions, that'd be really cool. Like one of the ideas that I had, Farcaster was really popular earlier this year, and I don't know if anybody's done this, but wouldn't it be cool to have a frame that you could add on to Farcaster that lets you do anonymous chats or private DMs between people? So there's all these decentralized applications that can be improved with small amounts of privacy that would make them better. So that's what I kind of mean by privacy preserving transactions. And John, I'm sure you have some things to add to this too.
I mean, I think the big thing to call out here is like the privacy piece is very, I think, scary to people because of some of the things you mentioned, right? Like regulatory compliance. But there are ways to do this in a compliant and safe way. So I wouldn't, talk anybody off trying to explore something within this space. I think most of the use cases are probably going to come from the prior slide, but we would be very interested in seeing some privacy preserving types of things. And I imagine there are, potentially some interesting applications of, privacy preservation in some kind of games. I'm not a big board game player or just general game player. Like I used to play a lot of video games, but I imagine there are probably games that would benefit a lot from certain things being private, at least until, other parts of the game are until you get to certain parts of the game where maybe certain things are revealed. So I think, we tend to think about transactions and messaging and more real like worlds, like use cases, but there may be some interesting ones in the gaming space that maybe people could potentially consider and think about.
Yeah, well, we got a couple of demo applications. They're nice and simple demo applications, but one of them was at a hackathon. So zk Mastermind took a nice open source application and made it use zkVerify. See, Mastermind is a straightforward 4-color board game, and then proving that you got the answer correct in a certain number of turns. It's a simple application of it, but since it's open source, there's also a template, and it demonstrates to developers on how you can use zkVerify in a game like that. Another one with one of our partnering sponsors, Sindri. So Sindri makes really great tools for developing zk applications, and they also have a way to generate proofs. And so we have a game, Sudoku, and you play Sudoku, and when you think you got it correct, you can have Sindri generate a proof that it looks like it's correct, and it goes to zkVerify and demonstrates through the verification that the whole zk loop has been closed. So those are basic games, but like we said earlier, there's other things that you can do with different games. So I encourage you to go to our blog post, look on x.com, see where the links are, go sign up for our hackathon for DevFolio. Like I said earlier, we already have $24,000 in prizes that are available. That are some of them are very specifically defined, and some of them are pretty wide open as to just the best application. There are a number of rules. So like John said, we've been to a number of hackathons earlier this year, and so we see what rules of the hackathon work well. So make sure you look through those. But we really encourage you all to join the hackathon, start building, and we're looking forward to it. So thank you. John, you got anything else?
I think I'll just echo what you just said, right? Really, really looking forward to this. We really could, we really want the help of the community to kind of build on top of zkVerify. It's super, super, super important. So I encourage everybody, to the extent that they can, participate, find people that, you can participate with. If you are a developer, aren't a developer, if you need any help on anything, feel free to reach out. There are so many ways to get in touch with us, whether it's through Discord, x.com, email. You could send a carrier pigeon if you want to, although maybe I shouldn't reveal my address. So yeah, definitely encourage everybody to get in touch, and we'll see what we can do with this thing.
And I'd love for us to have worldwide participation. I know we've got so many supporters in Asia from Horizon, great group of people in Korea and China. We've got 2 of our team members that are in Singapore. If there's a potential language issue, we have people on the team that speak many different languages. So really we want this to be a worldwide hackathon, and love for as many people as possible to participate. So we'll see you on the next live stream, and thank you very much.
Thank you.